Hi students, myself Kale S.L, रयत शिक्षण संस्था RBNB College Rampur. 12th Science Mathematics Part 2, Lecture number 2nd, Topic Application of Definite Integration, Exercise 5.1. In the first lecture, we have seen how to find the area under the curve, area under the single curve, and area bounded by two curves, and also we have completed first question in exercise 5.1. Now we will start here question number 2nd. So see here, question number 2nd, find the area of the region bounded by the parabola y square is equal to 16x and it's a lattice rectum. We know the basic of parabola, we have learned in the 11th standard. There are four types of parabola. Y square is equal to 4ax, y square is equal to minus 4ax, x square is equal to 4by, and x square is equal to minus 4by. These are four parabolas. And the figure of first parabola, here if we know a, if we know a, then we can find so many things of the parabolas. Endpoints of lattice rectum, length of lattice rectum, equation of lattice rectum, equation of directrix, coordinates of focus. So once we know a, then we can find. See here, suppose this y square is equal to 4ax, we draw the figure like this. Y square is equal to 4ax. Here parabola touch to y-axis. So y-axis is tangent to this parabola. Y square is equal to 4ax. Now here focus of this parabola is s is equal to a0. We take a from this 4a. From 4a we find a. So focus is a0. So here distance is suppose a. So it is s of a0. And from this focus, draw the segment joining 2 points of the parabola like this. So this L dash is the lattice rectum. And the end points of lattice rectum we can find. Here x coordinate is a, here also x coordinate is a. And now here this distance is a on the positive side. On the negative side, suppose this distance is a, and draw the line parallel to y-axis. So here x is equal to minus a, and x is equal to minus a means x plus a is equal to 0. This is the equation of this directrix. This is the directrix. Here O. So this distance is a, this distance also a, and we assume this distance as twice a. This distance as twice a. This distance as twice a. So the distance of this length of this lattice rectum is 4a. Total length is 4a. This 2a and this 2a. So the y coordinate here it is 2a. But in the fourth quadrant, so it is minus 2a. And here in the first quadrant it is 2a. So these are the end points of lattice rectum. Get it? So if we know here a only, then we can find the focus, that is s of a0. Then end points of lattice rectum, that is a to a minus 2a. Length of this lattice rectum L dash, that is equal to 4a. Length of L dash, that is equal to 4a. And here equation of the directrix, that is x is equal to minus a, so x plus a is equal to 0. And this distance, suppose here this we call here p, suppose this p, and this suppose here m. So pm or ps upon pm, we take this ratio, and if this ratio we know it as a eccentricity, and for parabola if that e is equal to 1, for parabola we take e as a 1, then we find the standard equation of the parabola. Get it? So this is the basic information for the parabola. Now see here, we have the parabola y square is equal to 16x and it's a lattice rectum. So consider y square is equal to 16x. Comparing with y square is equal to 4ax, therefore we get 4a is equal to 16, and therefore we get a is equal to 4, and therefore focus is equal to, focus we denote it by s, that is equal to a0, and a here 4, so it is 40. Focus is here 40, and therefore equation of lattice rectum, we know equation of lattice rectum is x is equal to a. So equation of lattice rectum is x is equal to a, means here 4, x is equal to 4. Now we draw the figure. So here y square is equal to 16x is the parabola. This parabola touch to y axis. Suppose this is the parabola and it touch to this y axis. So y axis is tangent, and here this is the x axis, here O, and this parabola is y square is equal to 16x. Now here let us say x is equal to 4, x is equal to 4 is the lattice rectum. So here 1, 2, 3, 4, so we assume here 4 and draw this lattice rectum. This is the lattice rectum whose equation is x is equal to 4, and on this y axis x is equal to 0. Now we have to find the area between the parabola y square is equal to 16x and this lattice rectum, that means this region. So we have to find this area. So this area is bounded by the given parabola y square is equal to 16x and the line x is equal to 4, and therefore here required area is equal to area of region. We give here name O, suppose here A, here B, here suppose C, O, A, B, C, O. Area of region O, A, B, C and O. And this is equal to, we find the area of this region and doubles, we get here the required area. Firstly find the area in the first quadrant and double it, so we get the area of the required region. Means here 2 times area of region, 2 times area of region O A B O. So this is equal to, required area is equal to 2 times definite integral x from 0 to 4. Here x from 0 to 4. So lower limit is 0 and upper limit is 4. Here dx, and here we take y dx. Now y we take from parabola y square is equal to 16x. So y square is equal to 16x. Here we write, since y square is equal to 16x, so y is equal to plus or minus root of 16 is 4 and root of x is root x. So here we take y is equal to 4 into root x in first quadrant. And therefore we get here 2 times integration from 0 to 4. Why we put 4 into root of x dx. Take 4 outside the integral, 4 to the 8, and here integration from 0 to 4 root x means x to the power half, and integration of x to the power half is x to the power half plus 1 divided by half plus 1, means x to the power 3 by 2 divided by 3 by 2 from 0 to 4. Now take this 3 by 2 outside the square bracket, we get 8 into 2 by 3. This 3 by 2 become 2 by 3. Now put x as 4. So 4 into 3 by 2. 4 into 3 by 2 minus x at 0. So 0 to the power 3 by 2. So we get here 8 to the 16, 16 upon 3. 16 upon 3. And 4 to the power 3 by 2, we know we take the square root of 4, that is 2, and then take its cube, that is 8. So here it is 8 minus 0 to the power anything, that is equal to 0. Now 8 minus 0 is 8. 8 into 16, 16 8s are, that is 128. So it is equal to 128 upon 3, and here it is area, so square unit. So this is the required area. We call it as A as the required area. Highlight this solution. So now we see here next second problem. So second problem here, y is equal to 4 minus x square. Question is common, that is find the area of the region bounded by the parabola. And second problem, y is equal to 4 minus x square and x-axis. We have to find the area bounded by the parabola y is equal to 4 minus x square and x-axis. Now in the previous example, parabola is of the type y square is equal to 4x. Here parabola is of the type x square is equal to 4 by or x square is equal to minus 4 by. So solution, consider y is equal to 4 minus x square. Carry this x square to left side, so plus x square. Carry this y to right side, so it is minus y plus 4. Minus y plus 4. Now here this parabola is of the type x square is equal to minus 4 by. Get it? So there are, we know, 4 types of parabola. Here y square is equal to 4ax like this. Y square is equal to minus 4ax like this. Here this is y square is equal to 4x. This is y square is equal to minus 4x. This is x square is equal to 4 by. And here this parabola x square is equal to minus 4 by like this. X square is equal to minus 4 by is of the parabola this type. But when x square is equal to minus 4 by, here x square is equal to minus 1 and plus 4. Means this parabola x square is equal to minus y plus 4 passes through the point 4 on the y-axis. Get it? So we draw this figure for our problem. X-axis and y-axis. So this parabola is of the type like this. That means this parabola passed through this point. Here point is 4. Here point is, suppose P of y coordinate is 4 and x coordinate is 0. So we put here x as 0 and y as 4. So we have to find the area bounded by this parabola y is equal to 4 minus x square and x-axis. This x-axis means we have to find this region. Get it? We have to find here this region. Now here this parabola y is equal to 4 minus x square and x-axis. The point of intersection of these two is, suppose here A and B and here origin. So we have to find the required area APBOA. We shaded here. So how to find now? Now here find the points of intersection of x-axis and this parabola. So on the x-axis, y is equal to 0. We know on the x-axis y is equal to 0. So we put y is equal to 0 in this parabola, and therefore we get here x square is equal to 0 plus 4. 0 plus 4. That means x square is equal to 4. That means if we take the square root, so x is equal to plus minus 2. That means x coordinate is plus and minus plus 2 and minus 2, and y coordinate is 0. And therefore points of intersection are, points of intersection of parabola and x-axis are, here x coordinate is minus 2 and y coordinate 0, and x coordinate is plus 2 and y coordinate is 0. We call this as suppose A point and this as a B point. So here the coordinate of point A is minus 2, 0, and the coordinate of point B is plus 2, 0. Therefore the required area is equal to area of the region, which region? A, P, B, O, A. A, P, B, O, A. So this is equal to, if we find the area of the region in the first quadrant and take its a double, then we get the required area. So it is equal to 2 times area of the region. O, P, B, O. So this is equal to, it is equal to 2 times, and now this area we find using the definite integral and lower limit from 0. On the y-axis x is 0 and here x coordinate is 2. So we take lower limit as 0. Here x is equal to 0 and here x is equal to 2. So lower limit as 0 and upper limit as 2, y dx. So this is equal to 2 into integration from 0 to 2, put the value of y. Y is here 4 minus x square. So 4 minus x square dx. So this is equal to, we separate the integral. So 2 into integration 0 to 4 dx minus this 2 into integration 0 to 2, this x square dx. So take 4 outside the integral, 4 2s are 8, and integration of 1 dx, it is x. And it is from 0 to 4. Get it? Minus here 2 as it is. Here integration of x square, we know it is x to the power 2 plus 1, that is 3 divided by same number 3, and it is from 0 to 2. Therefore required area, it is equal to, so here 8 in the bracket, put x as 4, so 4 minus x as 0. So minus 2, take this 3 outside the square bracket, so 2 upon 3. And now here x is 2, so 2 to the power 3, minus x as 0, 0 to the power 3. So here required area A is equal to 8 4s are 4 minus 0, that is 4. So 4 8s are 32. So it is 32 minus here 2 cube, that is 8. 8 minus 0, 8. 8 into 2, 16. 16 upon 3. 16 upon 3. So it is equal to 32 into 3. 3 2s are 6, 3 3s are 9, minus this 16 divided by 3. Here 2 cube is 8, 8 2s are 16. So here it is equal to 96 minus 16. 16 minus, see here Integration from 0 to 2. Integration from 0 to 2. We have written here 4. So it is 0 to 2. Here 0 to 2. So here 2 minus 0. So 2 minus 0, that is 8 to the 16 here. Here it is 16. 16 minus 16 upon 3. So 16 3s are 48. 16 3s are 48 minus 16 upon 3. So 48 minus 16. So 8 minus 6 is 2. And 4 minus 1, that is 3. 32 upon 3 square unit. This is the required area. So we have completed here second problem. So in this way we have completed question number 2nd. Now here question number 3rd. Find the area of the region included between. Question number 3rd now. Question 3rd. Find the area of the region included between and the first problem is y square is equal to 2x and y is equal to 2x. Y square is equal to 2x and y is equal to x. We have to find the area of the region included between the parabola y square is equal to 2x and the line y is equal to x. So to draw the figure, we have to find the points of intersection of these two curves. Here this is curve and this is straight line. So to find the point of intersection, to find the points of intersection of y square is equal to 2x and y is equal to x. So we put y is equal to x in this equation. So we get x square is equal to 2x, y as x, so x square is equal to 2x, and therefore x square minus 2x is equal to 0. We carry this, and therefore here take x common, x in the bracket, x minus 2 is equal to 0. This implies that either x is equal to 0 or this x minus 2 is equal to 0 means x is equal to 2. Now since here y is equal to x, since y is equal to x, here we write since y is equal to x, therefore points of intersection are x and y are same. So first is 0 0 and second point is 2 2. X also 2 and y also 2. Now here we draw the figure. We draw here figure. Y square is equal to 2x and y square is equal to 2x, y is equal to x. So we get here x square is equal to 2x. So x square minus 2x is equal to 0. So x into x minus 2 is equal to 0. So x is equal to 0 and x is equal to 2. Here problem we have to change. First problem is given y square is equal to 2x and y is equal to 2x. Y square is equal to 2x and y is equal to 2x. So here we take y is equal to 2x. So we put y as a 2x and 2x square, that is 4x square. So here 4x square. So here we take 2x common. So we get here, if we take here 2x common, so 2x minus here 1. 2x minus 1. And so we get here, so 2x, therefore we get 2x is equal to 0 and 2x minus 1 is equal to 0. So we get here x is equal to 0 and here x is equal to, carry first minus 1, it become plus 1 and then 2, that is x as 1/2. And so when x is equal to 0, what is y? So we find y from this. So y is equal to 2 into x is 0. So it is 0. Now when x is 1/2, y is equal to 2 into 1/2. 2 into 1/2. So this 2 and 2 get cancelled, so it is 1. And therefore points of intersection are, first point is x is 0, y is 0. X is 0, y is 0. And second point is x is 1/2. X is 1/2 and y is 1. Now we draw figure here. So parabola is of the type y square is equal to 2x. So it touches to the y-axis like this. This is the parabola. Here suppose y-axis means y-axis is the tangent to this parabola. Y square is equal to 2x. Now see here, points of intersection are 0, 0 and 1/2, 1. 0, 0 means here O, it is 0, 0. And 1/2, 1. X coordinate is 1/2. Suppose here x is 1/2. Then here suppose y is 1. Here y is 1 suppose. So this point is 1/2, 1. And draw this line. So we have to find this area. We give here name as A suppose, or we name it as a P. P of 1/2, 1. So points of intersection are O of 0, 0, this origin, and suppose here P of 1/2, 1. Now we have to find this shaded region, that is the area of this shaded region. We give the name as here suppose A and here suppose B. So we have to find the required area OAPBO, and this area is bounded by the parabola y square is equal to 2x and the line, this line whose equation is y is equal to 2x, and therefore the required area is equal to area of region, which region? OA, then P, then here B and O. So this area is, now this area is bounded by the two curves, that is y square is equal to 2x and y is equal to x. So we take area under the parabola y square is equal to 2x and area under the line y is equal to 2x and subtract that. So this is equal to area under parabola. Here upper curve is parabola, so area under parabola minus area under line. Line is here, y is equal to 2x. So this is equal to area under parabola. So this is bounded by the line x is equal to 0. Here by y-axis means x is equal to 0, and here x coordinate is 1 now. Here it is 1 now. X coordinate is here 1 now. So we take integration from 0 to 1/2. Lower limit 0 and upper limit here 1/2. And y dx, y from parabola. Equation of parabola is y square is equal to 2x. So y is root 2 into root x dx. So y square is equal to 2x. Here y square is equal to 2x. If we take its square root, so y is equal to plus or minus root 2 into root x but we take plus because it is in the first quadrant, and therefore root 2 into root x dx minus here integration from lower limit 0, upper limit 1/2, 0 to 1/2, here also y dx from line, and equation of line is y is equal to 2x, so here 2x dx, get it? So here integration from a to b y dx, it is from parabola, and here integration from a to b y dx, it is from line, because this shaded region is bounded by the parabola y square is equal to 2x. So firstly we find the area under the curve y square is equal to 2x, then take area under the curve y is equal to 2x and subtract that. We get the required area. Now we solve this. Take here root 2 common, constant. So take outside the integration. So root 2. And now here integration of root x. Root x means x to the power half. Root x means x to the power half. And its integration is x to the power 1/2 plus 1. That is 3/2 divided by same number 3/2. And it is from lower limit 0, upper limit 1/2. Minus here 2 is constant. Now integration of x dx, integration of x dx is x to the power here 1, 1 plus 1 2, so x to the power 2 divided by same number 2, and it is from 0 to 1/2. And now here this root 2 as it is root 2, and this 3/2 we write 3 divided by 2, 3/2, 3/2 here it is 2 divided by 3, 2 divided by 3. And now here x to the power 3/2, we put x as a 1/2, so 1/2 to the power 3/2, this 3/2, and minus x as 0, so 0 to the power 3/2, get it? Minus here this 2 and 2 get cancelled. If we take outside the square bracket 2 upon 2, now put x as 1/2, so 1/2 x as 1/2 its square, minus x as 0, 0 and 0 square. So we get here 2 into root 2. So 2 into root 2 upon 3. Now here 1/2 to the power 3/2. So 1/2 to the power 1/2. 1 to the power 1/2. Here I write here 1/2 to the power 3/2. It is equal to 1/2 to the power 1/2 to the power 3. Now here we take power half means it is square root. Square root of 1, that is 1. Square root of 2 is root 2. And its third power. Third power means 1 to the power 3 is 1. 1 to the power anything, that is 1. And root 2 to the power 3 means root 2 into root 2 into root 2. We take the product of root 2 as 3 times. Now here root 2 into root 2, 2. So 2 root 2. So we get here 1 upon 2 root 2 minus here 0, minus 2 upon 2 1, and here 1/2 square, that is 1 upon 4 minus 0 square here 0. So this is equal to 2 root 2 divided by 3 into 1 upon 2 root 2. Because 1 upon 2 root 2 minus 0, that is 1 upon 2 root 2, minus 1/4 minus 0, 1/4 into 1, that is 1/4. This 2 root 2 and 2 root 2 get cancelled. So 1 upon 3 minus 1 upon 4. So here it is equal to 4 into 1, that is 4, minus 3 into 1, 3, divided by 3 4s are 12. So it is equal to 1 upon 12. So the required area is 1 upon 12. We call this as A suppose and square unit. So in this way we get the answer of your first problem. A is equal to 1/12 square unit. Get it? Now here second problem, then fourth problem are of the same type. You solve yourself. I give here second problem and third problem. See here second problem is y square is equal to 4x. Y square is equal to 4x and y is equal to x. And fourth problem is y square is equal to 4x, 4ax and y is equal to x. Same problem. First problem is y square is equal to 2x and y is equal to 2x. Second problem and same problem is the Xerox of first problem. You solve yourself. Now we check the solutions of these three problems. We can check whether the solution is 1 upon 12 of this problem using the shortcut, that is 8a square divided by 3m cube. This is the formula to check the solution whether it is correct or not. In the first problem, we compare this y square is equal to 2x is equal to y square is equal to 4ax. So 4a is equal to 2. Compare the coefficient of x. 4a is equal to 2. So a is equal to 2 upon 4. That is equal to 1 half. That is equal to 1 half. And y is equal to mx. Here y is equal to 2x. We compare with y is equal to mx. Compare the coefficient of x. M is 2. M is 2. Now put these values in this formula. So here a is 1 half. So 1 half square divided by 3 m is 2. So 2 cube. So this is equal to 8 into 1 half square means 1 square is 1, 2 square is 4, so 1 upon 4, and divided by here 3, and 2 cube is here 8. 2 cube, 2 into 2 into 2. 2 to the 4, 4 to the 8. This 8 and 8 get cancelled. So here it is equal to this 1 upon 4 divided by 3. 1 upon 4 divided by 3. That is equal to 1 upon 4, 3 is 12. Answer is 1 upon 12 square unit. Get it? Now here what is the solution of the second and third problem? Second and third problem. In second problem, y square is equal to 4ax. 4ax is equal to 4ax. 4a is equal to here 4. We compare the coefficient of x to 4a. So 4a is equal to 4. So a is equal to 4 upon 4. That is 1. A is 1. Here y is equal to mx. We compare the coefficient of x to m. Y is equal to mx. So here coefficient of x is m and here coefficient of x is 1. So m is equal to 1. So what is the solution of this second problem? Solution of second problem is 8a square. A means 1. So 1 square divided by 3. M is here 1. So 1 cube. So solution here 8 into 1 square is 1 divided by 3 into 1 cube is 1. So it is 8 into 1, 8 upon 3 into 1, 3. 8 upon 3 square unit is the solution for the second problem. Now what is the solution for the third problem? Solution of the third problem is 8a square upon 3m cube. So here 4a, compare 4a is equal to 4a, that is a is 1. Here a is 1. A is 1 square divided by 3. M is here 1. M is here 1. Here a is a. A is a. 4a. So a is a here. So and m is here 1. So 1 cube. So here 8a square upon 3. This is the solution for the third problem. So solve second and fourth problem. Then we will see here third problem. Now third problem here, y is equal to x square and y is equal to 4x. Y is equal to x square and y is equal to 4x. We have to find the area of the region included between y is equal to x square and the line y is equal to 4x. So firstly we find the points of intersection of this parabola and the line. So to find the points of intersection, we solve y is equal to x square and y is equal to 4x. Now see here, y is equal to x square, y is equal to 4x, left side are same. So we equate a right side, that is x square is equal to 4x. Therefore we get x square is equal to 4x. Carry this 4x. Therefore we get x square minus 4x is equal to 0. Here take x common, x in the bracket, x minus 4 is equal to 0. Therefore x is equal to 0 or x minus 4 is equal to 0 means x is equal to 4. We get the x coordinate. Now we find the y coordinate from this equation or from this equation. So when x is equal to 0, then x is equal to 0, y is equal to 4 into 0. 4 into 0, that is equal to 0. When x is equal to 4, y is equal to 4 into, put x as a 4, 4 4s are 16. 4 4s are here 16, and therefore the points of intersection are, therefore points of intersection are here. When x is 0, y is 0, we call it as O of 0 0, and here x is 4, y is 16, we call it as P of 4 16. X coordinate 4, y coordinate 16. Now we draw the figure. Here parabola is of the type x square is equal to y. Parabola is of the type x square is equal to y means it touch to the x-axis. It touch to the x-axis. So parabola like this, here y-axis and x-axis, and parabola touch the x-axis means is of this type. Get it? X-axis, y-axis. Now here we write the point O of 0 0 here, O of 0 0, and P of 4 16. X coordinate is 4. Suppose here 1 2 3 4. Suppose here 4, and y coordinate is 16. Suppose here y coordinate is 16. So here point suppose P of 4 16, and join these 2 points O and P. O and P. Then we have to find this area. We have to find this area. This is the line. Which line? We have given this line as y is equal to 4x. This line is y is equal to 4x. Y is equal to 4x. And parabola is y is equal to x square or x square is equal to y. So here x coordinate is 4. X coordinate is here 4. So required area is bounded by the line y is equal to 4x and the parabola y is equal to x square. This parabola is y is equal to x square. Therefore required area is equal to area of the region here we give the name A here, suppose O, A, P, and here suppose B. Therefore required area is equal to area of the region O, A, P, then B, and again here O. So we find this area, that is equal to, so we take here area under the line y is equal to 4x. Firstly we take the area under the line y is equal to 4x, and then subtract the area under the line under the parabola y is equal to x square. So take the area under the line y is equal to 4x minus area under the parabola y is equal to x square. So this is equal to area under the line minus area under the parabola. So this is equal to area under the line. It is definite integral. So this area under the line y is equal to 4x is bounded by the line x is equal to 0, x is equal to 4, x axis and the line. So lower limit is 0 and upper limit here 4. Y dx, y from line here y is equal to 4x, so we directly put here 4x dx minus integration from here also area under the parabola y is equal to x square is bounded by the line x is equal to 0, the line x is equal to 4 and above the x axis, and therefore integration from 0 to 4 here also 0 to 4, and here y dx, y from parabola y is equal to x square, so it is x square dx. So it is equal to, now take 4 outside the integral, 4 integration from 0 to 4 x dx minus here integration of x square, that is x to the power 3 upon 3 from 0 to 4. Here integration of x dx, here also we take directly integration x square x dx, that is x to the power 2 upon 2 from 0 to 4. 4 outside the integral, integration of x is x square upon 2 and lower limit 0, upper limit 4. Here integration of x square is x cube upon 3 from 0 to 4. So here it is equal to, take 2 outside the square bracket, so 4 upon 2 and now put x as 4. So 4 square minus x as 0, that is 0 square, minus here 3 take outside the square bracket, x as 4, so 4 to the power 3 minus x as 0, that is 0 to the power 3. So here it is 4 upon 2 means 2, and here 4 square is 16, 16 minus 0 minus here 1 upon 3, here 4 cube is 64, 4 cube, that is 4 into 4 into 4, 4 4 is 16 and 16 4 is 64 minus 0. So this required area, now here 16 minus 0, that is 16, 16 2 is 32. Required area we call here A, 32 minus here 64 upon 3, 64 minus 0, that is 64, and into 1 upon 3, that is 64 upon 3. Now here 3 2 is 6, 3 3 is 9, 96 minus 64 upon 3. So here 6 minus 4, that is 2. And 9 minus 6, 3, 32 upon 3 square unit. Square unit. So this is the required area. In this way we have completed here third problem. So we take by shortcut method whether answer is 32 upon 3. I have given here formula as 8a square upon 3m cube. 3m cube. Here 3, so here 3. Now here y is equal to x square. This formula is for y square is equal to 4ax and y is equal to mx. This shortcut is to this formula. Now here x square is equal to y. So x square is equal to y, and here line should be x is equal to my. So x is equal to my. So we have to carry this 4 to here, so it become 1 upon 4. 1 upon 4. Now here we compare this x square is equal to y to x square is equal to 4ay. So 4a is equal to 1. 4a, here coefficient of y is 1. So 4a is equal to 1. So a is equal to 1 by 4. And here compare the coefficient of y as a m is equal to 1 upon 4, and put here a as 1 by 4 and m as 1 by 4 in this equation. So we get here 8 a square, a means 1 upon 4 its square, that is 1 upon 16, divided by 3 m cube, 1 upon 4 cube, 1 upon 4 cube, that is equal to 1 upon 64. 1 upon 64. So we write this as 8 upon 16. This 8 upon 16. 8 into 1, 8 upon 16. And we write this in terms of multiplication. So 64 in the numerator and 3 into 1 in the denominator. So 16 ones are 16 and 16 4s are 64, and it is equal to 8 4s are 32, and upon this 3. So 32 upon 3 is the answer. So in this way, by shortcut, we check whether the answer is correct or not. Now here we start last problem, fifth problem in this exercise. Fifth problem here, y is equal to x square plus 3. Y is equal to x square plus 3 and y is equal to x plus 3. Y is equal to x plus 3. Firstly, we find the point of intersection of this parabola and line. The point of intersection of parabola y is equal to x square plus 3 and y is equal to x plus 3 is, now here y is equal to x square plus 3 and y is equal to x plus 3. Left side are equal, so we compare the right side. That is x square plus 3 is equal to x plus 3. Here this 3 and 3 get cancelled. Plus 3 if we carry here, it is minus 3. So get cancelled. Carry this x. So we get here x square minus x is equal to 0. Now take here x common. So x in the bracket, x minus 1 is equal to 0. So here x is equal to 0 or x minus 1 is equal to 0 means x is 1. Now we put x is equal to 0 in this equation, or in this equation we find the value of y. So when x is equal to 0, y is equal to 0 plus 3. 0 plus 3, that is equal to 3. Now when x is equal to 1, what is y? So y is equal to 1 plus 3. 1 plus 3, that is 4. Therefore the points of intersection are. Points of intersection are x is 0, y is 3, means 0, 3. 0, 3. We call this point as suppose A. And this point x coordinate 1 and y coordinate 4, we call it as point B suppose. These are the points of intersection. Now we draw here figure. Now see here, parabola is y is equal to x square plus 3. The parabola is y is equal to x square plus 3, means here x square is equal to this y and carry this 3. So y minus 3. So x square is equal to y minus 3. Get it? Means x square is equal to 4by. Parabola is of this type, 4by. X square is equal to 4by. If it is x square is equal to 4by, then it touch to the x-axis. But here minus 3. So it passes through the point 0, 3. And therefore we draw here figure like this. Now shape of parabola we get from this standard equation. Parabola lies in which quadrant? First quadrant and second quadrant. So this parabola like this. Here this y-axis and x-axis, because this parabola does not touch to x-axis because here minus 3. Due to this minus 3, it passes through the point 3. So here y-axis suppose. This x-axis and this y-axis. Here origin. And this point is A of 0, 3. A of 0, 3. And next point B of 1, 4. Here 1 suppose, and here 4 suppose. So here B of 1, 4. And join these 2 points. Join these 2 points. This is the required line. Which line? Y is equal to x plus 3. Y is equal to x plus 3. And this parabola is y is equal to x square plus 3. Now we have to find this area. We have to find this area. So this area is bounded by the line y is equal to x plus 3 and the parabola y is equal to x square plus 3. Here we give the name as here P and suppose here Q. So we have to find the required area A, P, B, Q, A. Now on the y-axis x is equal to 0 and here this is the x coordinate, that is x is equal to 1. So to find the required area, we have to find the area under the line y is equal to x plus 3, which is bounded by the line x is equal to 0, x is equal to 1 and above the x-axis. Then take the area under the parabola y square, y is equal to x square plus 3, which is bounded by x is equal to 0, x is equal to 1 and x-axis, and then take the subtraction of these 2 areas. Therefore we write here required area is equal to, therefore required area is equal to area of the region, which region? A, P, B, Q, A. This is equal to area under the line, upper curve is line, upper here this is the straight line. So area under the line, minus area under the parabola, So this is the definite integral from 0 to 1, area under the line. So y dx, y from line, y is here x plus 3. So x plus 3 dx minus here integration from 0 to 1, lower limit 0, upper limit 1, and y from the parabola, that is x square plus 3. So x square plus 3 dx. So this is equal to integration from 0 to 1 x dx plus integration from 0 to 1 3 dx minus integration from 0 to 1 x square dx minus integration, because this minus sign, minus and minus. So 0 to 1 3 dx. Now this integration 0 to 1 3 dx, here also integration 0 to 1 3 dx, here plus, here minus, we cancel this without calculating it. We cancel this, here plus and here minus, same. So now take here integration 0 to 1 x dx, integration of x is x square upon 2 and it is from 0 to 1. And minus here integration 0 to 1 x square dx, it is x to the power 3 upon same number 3, 0 to 1. So it is equal to, put here x as 1, so 1 square upon 2 minus 1 square upon 0, or we may take here 2 outside the square bracket, so 2 in the bracket, 1/2 in the bracket, 1 square minus 0 square, minus here 1 by 3 in the bracket, 1 cube minus 0 cube. So this is equal to 1 square 1 minus 0 square 0, 1 minus 0, it is 1, 1 into 1/2, that is equal to 1/2, here minus 1 by 3. So subtraction of this is 1 into 3, 3 minus 1 into 2, 2 upon 2 3s are 6. So here 3 minus 2, that is 1, so 1 upon 6. So here it is equal to 1 upon 6 is the required area, square unit. Always write here unit. So A is equal to 1 by 6 square unit. This is the required area, and in this way we have completed here exercise 5.1 and also the chapter application of definite integration. Thus we have completed here 3 topics of integration, that is indefinite integration, then definite integration, then application of definite integration. So we stop here. Thank you.